Hello everyone, my name is Gaurang Gupta and today we will do a machine learning project which is surge price prediction. What we have to do is we are given with the data and we have to predict how much the price of the cab which is booked should be compared to the base price of the cab. What happens is that many companies and especially many cab services like Uber and others, they do that they place a extra charge over the base price whenever the demand is high to generate maximum profit for the company. It depends on the company policy that how much charge could be. So generally it is 1.5 to 2 times, even sometimes 2.5 times the normal charge, depending on the demand and the supply the company can offer. So let's start coding. So first we will run this cell. Here you can see I have all the paths in the folder. Here you can see the input data and all the files. Wait a minute. Here we have three CSV files and one folder. You can open it. I think so. Here you can see all the paths. We have some text files and with two CSV files. These text files are the just kind of, you can say, some metadata to understand the data. So let's start the first step, which is data description. For this, first we import all the necessary libraries. I'm using a random forest regressor as my model. You can use any other model, and if you use any other model, do comment the accuracy of that model so that I can know that whether that works better or not. So first we will import random forest classifier, then we will have to import test train split dot model selection, import train test split. Then from sklearn.preprocessing I will import label encoder. Preprocessing, import label encoder. Then from metrics I will get the precision and accuracy score, and also from this we will have to import one more thing, which is recall score. Now we will import our data. So first we will define a data frame, which is cabdf. This will contain the all the data from this cab ride CSV file. So pd.read CSV. Now if you think where is pd, so the pandas and numpy libraries are all already present. So here it this cell you get when you make the notebook from this place. Wait a minute. From this dataset place. When you click the new notebook, this cell is a default and it's given to you. You can use it, you can delete it. I chose to use it, so that's how you get the code. And then we will copy the path. And we will also import the weather data. Now we will run the cell. So now before moving on, let's first see what the cab and weather data has to show. So cab df.head. Here you can see we are given with distance, cab type, timestamp, destination, source, price, surge multiplier. This surge multiplier minimum is 1, so again we can't discount the prices. This is the ID, again just for database purposes. Product ID, that what product or what cab does the rider booked, and the name. So and then the weather data, weather df dot head. Here we have weather of different locations, the temperature, clouds, what about pressure, rain, timestamp, humidity, and wind. Now we will merge both the cap df and the weather df. How we will merge it? We will first create a column which will be common in both. And what will be the column? It will be this timestamp and the here the timestamp and this location. Now let's start coding the second step, which is data preprocessing. So first we will convert the timestamps are to a good thing, because here the timestamp is difficult. So we will declare a new parameter which is date time, and then we will populate it. Date time will be equal to pd dot to date time cap df timestamp, wait a second, time underscore stamp, which will be divided by 1000, and the units will be seconds. Same thing we will do for weather data frame. Pd dot to date time, wait a minute, weather df timestamp divided by 1000, and units will be seconds. Now we will create another column which will be merged date, and what it will be is cap df dot source dot as type string plus a hyphen, then cap df dot date time, which we used here, date time dot dt dot date dot as type str, and then plus cap df dot date time dot dt dot r r dot as type str. Now what I'm doing is I'm combining the source, wait a second, let me show you this so the source and this timestamp, well, the new timestamp, because we have converted the timestamp into date time. So I'm using date time and source and combining them to create a merged date. Same again thing we will do for wait a minute, what is that? Weather merge wait, merge date, weather df dot here it is, I think something different than source. Yes, it's location dot as type str plus then weather df dot date time dot dt dot date dot as type str, wait, columns. Here we have to put the string str, then weather df dot date time dot dt date dot r dot as type str. Now we have the merge date. So first we will use the label encoder now. Now we will update the weather index, weather df index, and update it with the merge date. Wait, merge date. Then we will create a new data frame which will be merged data frame, and that will be the merger of two data frames, which is cap df and the weather df. Now whenever you joining like this, it will match every column to every column. That's not what we want. So we will give it the column that on which you have to merge, or on which you have to select that the merger should happen, that which column should be common in both of them, and then you have to match only those values which are matching. It's kind of joins in SQL or in some structured query languages. In MySQL is most common. Again, I would recommend that if you don't understand this, look up documentation, and also look up what our joins are, because this is the concept of databases, especially the relational databases. So I will recommend you to check that out so that you can build an understanding. Or if you don't want, but again you can do it. And then suffix will be underscore w. Now this suffix is just given so that sometimes the columns are same here. Wait a minute, let me show you some column which is same. There it will not be, but it will show for date time. So I will print it so we can check. Then we will print this merge data frame, merge data frame, and I checked it that the rain column has some nulls. So first we will fill those. We will fill those with 0, and in place will be true. Then the merge df will get some more. Then we will remove some more nulls from it, not null. Merge df date time w, pd dot not null, merge df price, then merge df dot day, merge df day column we will make, which will be nothing but merge df dot date time dot dt dot day of week. And then merge df dot r equal to merge df dot date time dot dt dot r. Then we will build the search data frame, which will be merge data frame, and the condition is that the surge multiplier should be less than 3. multiplier should be less than 3. Then we will encode some labels. Product ID, that will be equal to lb dot fit transform, search data frame, product ID. And we will do the same for cap type. Now let's run this cell. I think it is showing the error due to this. Let's run it again. Why it is showing invalid syntax? So let's run it. Here data the data frame which we printed is there. I have changed some things which were errors. First of all, the suffix should be r suffix, and here it should not be units, it is unit. So these are the two things I made wrong. Now let's move on to feature selection. Now we will select the required features. So x will be equal to search data frame, distance, day, hour, temperature, clouds, pressure, humidity, wind, rain, product ID, and cap type. These will be the attributes we will use to predict, and y will be search data frame, search multiplier. So let's run it. Now let's start label encoding and data splitting. First we will define a label encoder. Then we will fit the labels. That will be 1, 1.25, 1.5, 1.75, 2, 2.25 and 2.5. Yes. Then we will transform our y, transform, not fit, transform y. Then we will get a feature list. So first let's get a feature list, which will be list of x dot columns, and then we will split the data x train, x test, y train, y test, which will be train test split x y. Test size will be 0.3 and the random state will be 42. Let's run it. It is executed now. We will move on to feature sampling. For feature sampling, we will use imb learn dot oversampling and we will import smote. Then we will define an variable sm and that will be this. Random state will be 42. Then we will sample the training features and training labels with sm dot fit transform not fit transform, it will be fit resample, and it will be x train and y train. Now let's run it. It is executed. Now we will move on to model training. For model training, we have to first select a model. I am using a random forest classifier as we have imported the library above. Let me show you where. Here we have imported random forest classifier. So let's build a model. For model, we will define a variable model equal to random forest classifier. The jobs will be 1, random state will be 42, and class weight should be balanced. Then we will fit the model on our training data and the y train. Then we will get the prediction by model dot predict x test. Now let's run it. Now let's move on to feature importance. So first we will get importances of all the features in a list, which we will get by model dot feature importances. Then we will get feature importances by joining feature and its importance. We will use round importance, 2 because we want to round it to 2 decimals, and for feature importance in zip. Wait a minute. Feature list and so that will be feature list importances. Now we will sort our feature importances and sorted feature importances. Key will be lambda x1 and the reverse will be true. Then we will print variable will be empty, and then its importance, which will be and we will format this with pair, which we will get from the sorted feature importances. So now the model is trained and the predictions are there. So let's run it. Now here you can see we have a here you can see we have all the feature names and their importances. You can see distance is the most important feature, then the product ID, then temperature, and so on. And now let's move on to evaluation of the model we built. So for evaluation we will import we already imported a accuracy score, so we will import the F1 score again. I haven't imported it above, so we will print F1 score, which will be y test, y pred, and average will be weighted average. And we will also get the accuracy score of our model, y test, y pred. Now let's run it. sklearn.metrics. Now here we got our accuracy and the F1 score. You can see we have a very good accuracy, about 95 to 96%. So that's good. Now we plot our confusion matrix. Port confusion matrix and confusion matrix display. And we will also import matplotlib.pyplot as plt. Now we will get the confusion matrix. Confusion matrix y test, y pred, and labels will be model dot classes. Then we will define a disp variable, which will be confusion matrix display. Let me copy it. Confusion matrix display, confusion matrix will be cm, display labels will again be model dot classes. Then disp dot plot and plt dot show. Now let's run it. What happened? Can't import confusion. Again I committed the same error. It will be from sklearn.metrics. So now our project is complete. Here you can see we have our confusion matrix. So the confusion matrix, you can see, is kind of just split into two colors. The yellow color, the top one, and then the purple, the bottom one. And here you can see there is not much of the gradient going on, because here we have a high accuracy, and so this is not a big issue. You can use any other color scheme. I am leaving it as a exercise for you to check out different ways to plot confusion matrix and different color schemes. So now our project is complete. Thank you for watching the video. If you like it, do like, share and subscribe to my channel, And if you need this notebook, this will be in the description. I will link it in the description. The dataset will also be in the description. So thank you for watching this video. Thank you very much.